Good morning. My name is Tim Johnson, and I'd like to welcome you to this morning's keynote speech here at our 77th annual conference. It's my pleasure and honor to introduce our keynote speaker for today, Dr. Tom W. Smith, who is a senior fellow at the National Opinion Research Center at the University of Chicago, and for nearly 40 years, director and principal investigator of the General Social Survey in the United States. Tom is a prolific scholar. His CV lists 25 pages, single-spaced, of books, reports, and articles, which translates into over 600 publications. Tom is also a professional historian, which is evident in a number of his publications that present longitudinal analyses of survey and polling data concerning a variety of important social and political issues. One of several papers he's presenting at this conference is also historical in nature, a paper in which he discusses the founding of WAPOR during the immediate post-war years in the late 1940s. He has an extensive record of service to professional associations, of course, including WAPOR. In addition to committee service and leadership, he served as WAPOR's vice president, president, and past president from 2009 to 2014. Currently, and maybe not too surprisingly, he serves as WAPOR's historian and is leading the development and writing of an official history of our association. Watch for that next year. Tom's work has been acknowledged by both the American Association for Public Opinion Research, known as WAPOR, which has twice recognized him with its Innovators Award and also with its Book Award. In addition, he has received the WAPOR Award for Exceptionally Distinguished Service in 2002, and WAPOR has awarded him the Bob Worcester Prize for his paper published in the International Journal of Public Opinion Research, previously in 1994. Tom has amassed an amazing record of contributions to WAPOR and the field of global public opinion research, and it's my pleasure now to introduce him as one of our keynote speakers for the conference. Ladies and gentlemen, Mr. Tom Smith.
Okay. All right. All right. So as you can see, we're speaking today on data quality and amid measurement disruptions. So here we have the theme of our conference here, the soul of public opinion research, liberty, quality, and humanity. Now, as I see it, the liberty and the humanity are our aspirational goals. We want to take in support, advance liberty, and we want to serve humanity. But the only way we can do that is if our public opinion research has quality. And that's what I'm talking about. So, the soul of public opinion research, there's another soul here. Here's a quote from the famous Swedish botanist Linnaeus in 1735. In Latin, Methodus animae scientiae, or in English, method is a soul of science. So we're talking about, once again, the metaphor of soul here, method here, being this case. So what is it about method that Linnaeus is talking about? He's talking about two things. In a general sense about the scientific method, but in a more specific meaning that you must have methodology that can actually accurately measure the scientific phenomena you're trying to measure, in our case, public opinion. So let's start with this. Quality is in measuring the true value. Now, you probably have been introduced to the concept of the true value when long ago you took that sampling theory course, and they talked about the measures of the true value, which often is unknown. And how do you take and measure something that's unknown and think that you're measuring it? Through solid methods. I'll expand a little bit on this. Accuracy is the first thing you want, which is really what I just said. If you're measuring the true value, you're being accurate, okay? And then reliability. These, of course, are entirely concepts that you all know. Reliability is that when you measure something, and if there's no true change, and you measure it again, you get the same result. I think of an example of something that may be accurate sometimes and not. If we can think of the old analog clock that doesn't run at all. It's accurate twice a day if you're using a 12-hour clock rather than a 24-hour clock. And any other time you consult the instrument, it's totally inaccurate, okay? It's not reliable. Validity. Something may be measured accurately, it may be reliable, but if it isn't measuring what you intended to measure, it's not valid. So that's the third thing. And then the fourth thing, to be announced. Later in this talk, you don't have to wait too long, okay? We're going to talk a lot about the total survey error. Now, there are two components in total survey error. There is variance or random error, and there is bias or systematic error. And from each of the components here, and we're going to greatly simplify this chart in the wink of an eye, there's only half as many boxes because each is showing two paths flowing out of it. The red, let's say, is variance, and the black, we say, is systematic error. So in this rendition, this is my personal rendition, I've seen a dozen different renditions of total survey error. No two are exactly the same, but this is the one I use. You have, this is in effect typology of components, or to flip it around, a typology of the components of error here. If you look to the rightmost, which is the end of each of these subdividing boxes here, there are 35 boxes. So there are 35 components in which must be understood. The measurement aspect of each of these must be understood because each one is a component of the total error. The error from each of the 35 boxes on the right flows into the total survey error box on the far other side. However, the 35 boxes do not show the full complexity of things. Here we have the 3 boxes that were on that previous slide, non-response, refusal, unavailable, or other. And then we look at parts of the survey instrument. Is it unit non-response, the first column there? Many surveys have supplements, SAQ, self-administered supplements, as part of their survey. So that's the middle one, and they all, of course, have individual items here. So here, we've now taken 3 of the final boxes here, and we now have somewhere between 6 and 9 things. I say a range because there's a couple listed there as null, where there may or not really be anything there. But there's all these other components that last. Some of them it's very simple. You can refuse to unit, you can refuse the supplement, you can refuse to answer a question. But you may, if you refuse to do the survey, of course you don't get to the other 2. But you can take and agree to do the survey, and then you can refuse the supplement. But answer all the questions, or any combination of that. So the whole point here is that this elaborates on the issue of just refusal and just unavailable and just other. And we have to understand the error component of all of those parts. Give you a second example. Here we have what I called medium in those 35 boxes, but think of it a little simpler, perhaps as mode. Well, here it breaks down by 3 other aspects. Is it visual, is it audio, or is mixed, which is simply both of them being used as part of the data collection? And then, is there a computer being used or not being used? And is there an interviewer or not an interviewer there? And of course, you see all these acronyms here, most of which are familiar to you. CAPI, CADI, PAPI, TI, maybe less common than some of them, telephone interview. And things there. Again, to really understand, one must understand the mode measurement effects of each of the different versions of our doing surveys. Now, another complication. The total survey error model as these series of nested boxes, and I talked about the elements of error in each of the components flowing into the total, is inadequate because it acts as if there's no interaction across the components. Now let me take and give you just a few examples of what I mean by interaction. And here is kind of classic path analysis showing. So let's just take A here. You start with a mode, and there are some direct mode effects. A self-administered versus an interviewer effects in general, let's say as a mode effect here. But then there is a respondent, and given a certain mode, characteristics of respondents will act differently. So let's say this is a telephone survey. Well, if someone is hard of hearing, or if someone is not highly competent in the language that the interview is being given, then they're going to take and have there's a special mode effect acting through those characteristics of the respondent, for example. So there's direct and this interaction through the characteristics of the respondent. For the second one, we have an interviewer, and a good interviewer will take and administer the survey correctly, interview the right respondent, ask all the questions correctly the way they're asked, and so on. But there still would be an interviewer effect as opposed to a self-administered effect in which there's no interviewer effect. And of course, one of the things that a poorer interviewer might do is be less successful in gaining an interview. And so there you will have non-response being affected by characteristics and abilities of the interviewer there. So an interaction effect there now. Let's just go down to D here as a third example. Content. Well, the survey content, that is, what is the substance of the survey, affects things. In the United States, at least, health surveys, on average, get the highest response rate because health is something everyone has, and health is something that everyone recognizes as important. So they usually get a higher response rate. So if that's the content, non-response will be reduced. Now, if it's some very narrow topic that of little interest or even not knowledgeable to many people, then non-response will go up because of that content there. Now, again, the individual characteristics of the respondent affects this. If this is a topic, let's say sports, a survey on sports, and you're really into sports, well, if that's a characteristic of you as a respondent, that's going to affect how things go, and I won't take and elaborate any more on this. by just saying that these are 3 of the 5 examples here. And so let's see, how can we build the interactions into our illustration? This is not the way to do it. Look at the title up here. Essential Communication Linkages for a Modern Force Multiplication System. Now, this has nothing to do with surveys. I am able to vaguely tell you it has something to do with the Air Force, okay? What modern force multiplication scheme is exactly, I can't tell you, but they sure think it's complicated. And so I'll accept that as true. Not only is it this incredible series of back and forth arrows between all kinds of different things, AWACS are a certain kind of airplane, but you see on the far right here, an incompleted circle, which means that there's something there they couldn't even squeeze into their slide, okay? So the simple thing is, visually, there's no way to take in to show this, but it's something that we must pay attention to. So, moving on here. The other aspect, a third, let's call it limitation of traditional total survey error, is that it was always developed with the idea of there is a survey, and you're looking at the error in that survey. Well, that's fine and absolutely essential, but most of the most important usages of surveys involve more than one survey. So here we have time series. The General Social Survey, of course, is built on this thing of time series of more than 20 surveys from 1972 to the 1924 survey in the field right now. Panel waves. A panel survey of income dynamics has been re-interviewing people and family dependents who have become members of families since, I believe it was 1968. Many, many waves there. And comparative. Comparative would include both cross-national, cross-cultural surveys and any other kind of comparative survey you're doing, maybe comparing several different professions, for example. But we're interested today in the latter of these, although some reference to time series will come up a little bit later in the talk. All right, so I don't like to read quotes out often, but this will be one of the exceptions to my preference here. Quality problems present in single population surveys are magnified in 3MC surveys. In addition, there are quality problems specific to 3MC surveys, such as translation processes. 3MC, as you see, I've given you the definition down there if you're not familiar with it. Multinational, multi-regional, and multicultural. This is a quote from the AP WAPOR Task Force on Quality and Comparative Surveys, 2021. So, without going on to the next point, I will say, if you have not, this is online on the APOR and I think WAPOR's websites. If you haven't looked at this document, look at it. This is a very valuable document here. Okay, so now we're back. You've seen that before, but now you see under each of the boxes, there's a kind of ghost second box. And this represents the simplest example of comparative surveys, a bilateral survey. For each of the boxes, each of the surveys have the same component. And in getting your comparative surveys to be comparable, that is to say, that they are really measuring the same thing in the same way to the same degree and everything else, you have to take and understand, is sampling, is a true population, for example, comparable across countries? Or we can get down to the wording, and that's where translation comes in. Is the wording comparable across countries? Simplest example here, but bilateral studies are the most minimal and the least powerful of cross-national studies. Bilateral to multilateral, okay. Now, with just 10 countries, there are 45 bilateral country comparisons, plus 35 components, which is 1,575 things to compare to see if you got it right. And that's only with 10 countries. I've been involved in surveys with a little over 50 countries, and there are others that have well more than that, of course. And so, in addition, and so that number then becomes much, much bigger than. It's already a large number, 1,575 things, to understand whether each of the countries, just take the simplest example of target population being defined, whether it's really comparable across that, and then the second component and the third component, and so on. Now, plus, as you see written right there, there is a wording comparison or translation issue for each question in the survey. So that multiplies the things you have to pay attention to by the number of questions in your survey. And remember, that's wording, and wording is only one of 35 boxes that we've talked about here. All right. So, so this is another one, which essentially I'm just going to read the whole thing. You can take a look at it as I do that. The total survey error paradigm is a valuable approach for comparative studies for several reasons. One, it is a blueprint for designing studies. Each component of error can be considered to be an object of minimizing comparison error. That's the idea of each of those boxes. In each of those, there is a potential for comparison error if you haven't optimized the comparability on each of the components. Second, it is a guide for evaluating error after the surveys have been conducted. One can go through each component and assess the level and comparability of the error structures. Third, it can be a methodological research agenda for studying error and for the design and experiments and other studies that might be needed to really understand it. Fourth, it goes beyond examining the separate components of error and provides a framework for the combining of the individual errors into the components in which are the overall sum. And finally, by considering error as an interaction across surveys, it establishes the basis for a statistical model for handling the error across surveys. And I want to emphasize what this last point is. It's a theoretical statistical model one think of, and one that cannot readily be implemented with our current abilities here. So back there to our standard chart, and let's move on from there then. I'm going to take and give one small extended example. And the point I want to make before I talk about this example here is that one could take and have to give dozens and dozens of examples to try and cover all the elements. And this is just one to take and show you about how you might try and optimize things. And it's also going to talk about the simplest example of just 2 languages here, okay? So keep this in mind. as we do this. So, translation experiment. In 2006, after asking the National Science Foundation for almost 20 years to give us extra funds to add Spanish to the American instrument, we finally got the support for that, and Spanish was added. We used what was then the developing TRAP-D method there. It had been fully perfected, but it was the best translation method at the time. And we then did a detailed analysis in which was conducted on 35 attitude items that were selective of the several hundred that were on the survey to take and give us a manageable task of looking at it. And we did this analysis within the Hispanic population on the survey, which was 427. And we broke them into 4 groups based upon questions that we had on the survey. There were the English monolinguals, again, Hispanics here, which they did the survey in English, and they could only have done it in English. They really had no manageable Spanish any longer. Bilinguals, who used English as their preferred language, they had the choice between English and Spanish, and bilinguals who used their Spanish ability there rather than their English, although they had they gave responses that indicated they were capable in both language, and then Spanish monolinguals who had only Spanish and therefore only were given the Spanish interviews here. And then we looked at 4 criteria in analyzing across these 4 groups. So the analysis I'm about to refer to is across all these 4 groups. Was there a statistically significant difference across the 4 for each of the 35 questions? Was the statistical difference across the bilingual, was there a statistical difference also across the 2 bilingual groups? Third, was the difference across the bilinguals the largest difference here? And did the differences remain when they were controlled for simulation demographic variables? So not surprisingly, for example, the Spanish monolinguals versus the English-only Hispanics had been in the United States. Many more were born in the United States in one case, and very few in the other case, and so on, and had a lot of different demographic things, and we looked at that. And so we used those criteria, and we identified 4 of the 35 questions, showed some signs, made some criteria for looking at closer to see if there was a translation or language issue here. 3 of the 4 were very small differences. They had been flagged, we looked at them, and it was not clear that there was any language issue. And again, it was just a few percentage points, but some significant differences here. But there was one large difference here. This was a question on happiness. In English, the question asks, are you very happy, pretty happy, or not too happy here? Okay, so we're only going to keep it simple, look at the first category, very happy. In English, 37% of Hispanics were very happy, and in Spanish, only 15%. Not a small difference here, 22.1 percentage point difference here. We examined the Spanish language, and it became very clear as a hypothesis what the problem was. The problem was that the middle category in Spanish was seen much more positive in Spanish, and therefore attracted responses out of the very, or the very happy response into the middle category there. So we reviewed it, we came up with a new translation, and we filtered it on the 2008 General Social Survey. So again, we're just looking at the very happy percentage. The first column here, first row, I should say, 2006 is the numbers we just looked at, the 37.1 and the 15%. And in 2008, you get a 39 and a 13. And particularly because the Hispanic sample was smaller in 2008, while there's a little difference there and the difference is a little greater in 2008, there's actually no statistical difference between the observations. In other words, you really replicated the initial finding with the original wording. And then with the new wording, there's no English wording, so nothing under the English column. There's just a new Spanish, 39% very happy, which if you go back to the 2018, very happy in English, exactly the same. So our second stab at getting a good comparable thing on 1 out of 35 was not only documented by the consensus that it was a better translation match, but by this experiment, which shows that it is here. And that's a point that I wanted to make and made earlier in a talk in this conference, which was translation, besides following the very best method, like TRAP-D, is helped if there are experimental and quantitative studies being done at translation also. Okay, we've now filled in the missing fourth important characteristic, comparability, or in a different part of the field, the term would be functional equivalence there. And that is the fourth aspect of, so a survey that is accurate, reliable, valid, and has functional equivalence, to use the second term there, is a survey that has attained quality. Now, we've been using, and for very good reasons, the total survey error paradigm here, but this is new to the being applied to comparative research, only going back about 10 years. And the functional equivalence paradigm goes back decades earlier than that. To really do this right, we want to use the best of both of those. That's the point here. So what I'm saying is, while I've been advocating and do strongly advocate total survey error paradigm as important to follow in trying to take and maximize quality, it's not the only thing you need to pay attention to. So just look at here, there. One thing by looking at equivalent approach and all the literature on that, huge literature on that, is it focuses on the most important cases of comparison error. So remember, there's 35 different components, but the functional equivalent literature can take and tell us which ones to pay particular attention to. And of course, wording and translation is one of those. I did not pick translation at random as an example to take and pay attention to in comparative research. And second, it has the essence of the functional equivalent approach is on comparability. There's no element of comparability in the original total survey error perspective there. So this is, again, a thing. And there's this etiquette, which I won't go into, other than saying this has to do with some constructs, values, or beliefs that you're trying to measure, may be very indigenous and only exist in one or a few related cultures, and not easily relate to other cultures or even languages to take and try and explain those terms. And others are more universal. And then again, functional equivalence has paid a lot of attention, paying attention to this aspect. And the other thing that functional equivalence have paid attention to is the comparability of scales of multi-item measures. Again, this is something that is not a traditional part of the total survey error. Nothing that keeps total survey error perspective from being used in terms of that. But again, it hasn't focused on that. So these are just 4 examples of why you need to use something, in this case, functional equivalence, as an additional aspect to pay attention to. So here's another quote. Diligent attention is needed to apply total survey error. to reduce comparison error and advance comparative functional equivalence. It will notably improve data quality and increase the reliability and validity of substantive cross-national research. You can take that as true because I said that there. But also, I was very happy to find this quote, which I had written, a number of years ago, because look, we have the word reliability, validity appearing in that, and quality too. So just the kind of terms we've been, advocating that one needs to pay attention to. They're there. Okay, so now maintaining trends in the face of changes in mode and other measurement disruptions here. All right, so we've talked about what is quality, and we've talked about how one tries to obtain quality, and you've attained quality in theory by developing this good method, and now you're going to change the method. You're going to change your measurement regime here. The first law of studying societal change is the way to measure change is not to change the measure. So we're saying, all right, we're going to do that. We're going to violate the first law here, okay? Now let me say something about that first law. It is often that is understood to measure meaning a question, an item, the wording of a question. But it actually, if you look at the description of the first law in depth, it actually is all aspects. The measure is measure. What I'm going to suggest is to make that point a little clearer, I'm going to modify the first law. And I can do that because I wrote the first law too. So the way to measure change is not to change the measurement, just to underscore that it's more than just the wording of something. It's mode, for example. It might be, even if you're keeping face-to-face, it might be the way you train interviewers, for example. Now, we all know that following the first law is under immense pressure nowadays to change. We've already changed a lot, and more change seems to be inevitable. And the big change seems to be, of course, the change from traditional modes into newer modes. So less face-to-face interviewing, less telephone interviewing, more internet in various ways. Push-to-web surveys, web panels, all the new ways of doing it. Now, the related point down here, which is in the bottom, is that if you might think at first, oh, I'm just changing the mode, just that one little component. But that's where the interaction effect we talked about. Because changing the mode changes many other components in it. You, for example, almost always change the sample frame from what you had in a face-to-face or telephone, and they're quite different too, of course. The coverage tends to change. Groups that tended to be over or under covered sometimes change which ones they are. The response rates, at least early on, seem to go down in web surveys, and they certainly do in web panels because there's so many stages before you get to the people in the panel that the response rate from the original selection down to just before you draw the sample from your panel members and get the final non-response phase usually means that web panel surveys are well below 20% and often below 10% in terms of their combined survey thing. So that's what we have to remember, that this change from face-to-face telephone into internet versions is something that is a massive change in the measurement regime. Now, there's one highlighted phrase up there, and that's the heart of what I have to say here. Experimental designs. If you have a well-established method of doing it, particularly if that happens to be a time series study, and you feel you need to, or it even be maybe more pressing that you really have to change from the old method to the new. You only way to take a no if you are measuring true change across the switchover is an experimental design, in which an experiment you test the old mode and the new mode together. This is needed even if you happen to get results which are very comparable. 1% on a particular question, 35%, 36%, it's exactly the same. It's perfectly equivalent. Without an experimental design, you can't rule out the fact that the close distributional agreement wasn't an artifact of measurement change and not that you're measuring the true difference there. Maybe there had actually been a drop, but the measurement change created a systematic error showing higher than the true value there. So you have to pay, even when you don't see a red flag, you need an experimental design here. So one of the scientific points of scientific method is replicate your results. So here I argue that doing an experimental design just once is good, twice is better, and more is best there, is even better than that. So again, optimal is more than once. Now I'm going to give you two examples of where things are more or less being done the correct way here. I can assure you these examples were not picked at random, because the first one is a general social survey. And in my introduction, you've heard I've had a connection with the general social survey. So, first of all, during COVID, 2020-21, we did a number of studies using push-to-web methodology. And we learned a lot of things about how to adapt questions or being asked verbally, face-to-face, in a self-completion. Many of them seem to translate perfectly clearly, and some of them are impossible to take and duplicate, such as questions that had a pre-coded but unread response. You either don't include the unread response, in which, of course, that category completely disappears, or you include it, in which you get more responses than you would if you didn't include it. And we did experiments that just confirmed that there. So we did experiments in that year, and then in 2022 and 24, we're doing experimental designs between a mostly face-to-face traditional design and a push-to-web design with a face-to-face follow-up if we can't get the address space sampled respondents to take and respond to the web, in either because they are unable, they are totally, no web connections, don't know what the internet is, that kind of thing, or simply they don't want to do that, and then we try and do that version. So we're doing that in 22, and we're doing it again right now in 24, and the basis of those 2 years of experimentation, in 26, we will adopt a new method, which we hope will last going forward there. So, the European Social Survey is the second example. They're in round 12 are doing, which is 25 and 26, are doing dual mode studies. Their one mode is the traditional face-to-face mode for them. The other mode is essentially a push-to-web, but also with a mail-out paper questionnaire to take and help reach those non-internet, non-web populations there. And it's being done hopefully in every one of the ESS countries. So there you have the experiment being replicated across countries. And it's also based upon, first of all, going back almost 10 years to their setting up their online panel, Cronus, and then to a number of countries which during the pandemic did tests of WebThing based upon those two previous testing of internet use. And so this is a kind of approach that I'm saying that should be done. Okay, now we come to the summary here. And I've made the point about how technology, that is to say, methods that you use, determine how things work and how well they work. And in this case, we have 6 summary points because that's how many fit on one slide. Okay, so I'm not saying I couldn't have come up with a good 7th one, but I thought we'll get them all on one slide, right? Okay, so data quality means that by design and is actually implemented, the methodology utilized measures the true values. Second, high quality means that the measurement is accurate, reliable, valid, and when it comes to cross-national research, comparable. Rigorous application, third, of the total surveyor paradigm is essential in the design and execution of national and cross-national survey research. And the first law, the way to measure change is not to change the measure, but when you can't stick with that, when the measurement regime is changed, experiments need to be conducted to separate the measurement artifact from true change. And when any major change in methodology is adopted, there is a learning curve. And no matter how careful you are in adopting the entirely new measurement regime, a push to web or some similar design, only experience with the new measure will lead to it being optimized. So if you have a long time series and you're going to then make a radical shift in mode here, it would be best for you to take and try the new mode out on something else first until you gain more experience before you build it into taking recalibrating a 20, 30, or 40-year-old time series into that. Because again, the idea that there's no learning curve is not right. So somehow the clicker has stopped working here. See if we can go, there, fine. Okay, so 4 most important references here for you to look at. The one I already called out, the bottom one there. The first one is a website. So it's not it's a website about how to do it. And then these are just some of my previous writings which are led to most of the slides that you saw this morning there. Thank you. So we've got a little over 5 minutes if you want to do anything.
Thank you again, Tom. We will now have the drawing.
Good morning, everyone, and thank you for joining our Lucky Draw event.
We are PMI, a leading Korean research company with the largest online panel pool in Korea. We conduct various surveys, including marketing research, public opinion polls, and academic research. If you have any questions about our service or would like to learn more about us, please visit our booth. We'd love to chat with you.
Now we will be drawing 15 business cards today and 15 more tomorrow. So if you don't win it today, don't worry. You'll have another chance tomorrow, so be sure to come back again tomorrow. Wishing you all good luck.
Let's get started.
So for our first prize, we have a pouch bag. We're going to be handing out 5 pouch bags. Victoria Nem from Paper Lab. David Genentuli from U.S. Department of State. David? Not here, not present? Okay. Wingy Lee? Oh, over there. Okay. Porpan Buathong? Oh, there we are. Laura Silver from Pew Research Center. Laura Silver. Okay. Ellen Lust. 이게 5번째죠. Ksenia. Ksenia. 담당하시. 부스. 그러면 따로 네. Is there anyone that wants to have the remainder of the pouch bags? We have 2 more left. You can just raise your hand and we'll just give it to you. Okay, first one over there. Second one over there. There. All right. Our next prize is gonna be 3 pencil sets. It's our Korean traditional pencil sets. Jui Shrestwa. Fernell Ted Paginto. Fernell. Oh, over there. And Cees Faber. Cees Faber. Not here? Okay. Bonnie Wolf Boynish? Yeah. Sorry if I mispronounced your name. Okay, our next prize is gonna be the single towel set. 이거 하나 뽑아주시면 될 것 같아요. 이거는 네. Sworn Ration. Over there. Now our next 2 is gonna be our business card holders. Is also Korean traditional business card holders. Ireko Antadas. Congratulations. Danila Valenzuela. Over there. Okay. 네, 이제 투명했어요. Okay, so our last 5 is gonna be our Korean golden chopsticks and spoon sets. And we'll have the last 5 winners up on the stage so that we can take pictures together. Okay, first one. Simon Page. Raymond Kalia Jr. Raymond Kalia Jr. Okay, next one. Xavier DePouli. 5명. 네. 민영유. Okay, next one. Yishan Huang. Oh yeah, over there. Okay. Oh, yeah. Abdullah Ahmed. Abdullah Ahmed. Okay. Yi Hong Chen, our last winner. Yi Hong Chen, Yihung. Not present. Watanabe Kentaro. Watanabe Kentaro. Lee Tai Di. Okay, we'll just do the. Oh. Okay, we have our last winner then. Let's just take a quick picture and then yeah. Oh, thank you guys. Oh, come in the middle. You can come in the middle. Yeah. All right, thank you so much. We'll be back tomorrow, so be sure to come back and win your prize. Thank you.
Lunch is served.